So I just made a 15-minute video and there was no sound. Just my damn luck. So I don't know what happened. Anyway, what I'm trying to do is work out the details on this points conversion, converting to the GN250, Suzuki GN250 electronic ignition, and trying to figure out if this trigger that Jack come up with is going to work. It's off of let me look here, Yamaha RXZ, an RXZ 135 two-stroke. It's a little bitty thing. Here's another one that I've already beat up. But here's the TCI trigger. It normally goes on a TCI bike. And here's the other trigger. And if you look at them height-wise, they're pretty close to the same. And the height's real low. You actually, there's the TCI trigger installed. And there's, I'd guess maybe, if you're lucky, 1/8 of an inch clearance between it and the cover that goes over the alternator. So that's my bike's been running the GN250 electronic ignition all summer long. Appears to be working just fine, but it's using the 80 and up TCI trigger. So for the points conversion, we got to come up with a trigger, and the closest candidate found so far is this little Yamaha one that will fit. It's about the same height. The problem with it is it's magnetic, and the TCI trigger is not. So the TCI trigger is an iron core and copper coils, and it's looking for a magnet for a trigger signal. The two-stroke one is a magnet, and it's looking for a little piece of iron to run across it. So I'm trying to figure out if I can use a magnet, because I've already modified one of the rotors with a magnet. So what I've done, I'm not going to go back through all of this. I jigged up the TCI magnet in the vise and chucked this up in the drill and spun it. There's two triggers on there, so two pulses per revolution. The drill's rated to 1600 RPM, so simulating 3200 RPM. And what I got with the TCI with the magnet, I got 159 millivolts as a high on the trigger and a low of minus 213 millivolts. So I played around with the RXZ, and the best I got with it, the magnet against magnet actually got me the closest. I tried it with the just with the iron slugs for triggers, and it was quite a bit lower. But using the magnet, I got a high of 137, a low of minus 99 millivolts, which is the closest I got to the TCI's 159 and minus 213. So I'm going to pause this for a minute, and I'm going to set everything up, and I'll show you how I did it. I'm just going to demonstrate it one time. Alright, so the magnet triggers are chucked up in the drill, and the fluke meter set at millivolt, and it has a minimum maximum record function. So we're going to set that, and it says it's recording. Now I can set this up, get it up close. Alright, there it is, right across from it. So theoretically, if that's 1600 RPM, that should be simulating 3200. And now we can look, and we got a max of 83 millivolts and a minimum of 82, minus 82. So let me clear that. We'll try it one more time. I'm going to have to set up a better test rig here so I can try different distances between the trigger coil and the magnets and see what it's going to take. But basically what I just did there was moved it in and out, varying the distance, and it's going to record the maximum and the minimum. So we got a maximum 106, minimum minus 72. So I'm guessing that's going to get us close enough to work. I just got to figure out the distance. That's about it.